The increasing use of new technologies and the need to develop new communication infrastructures and network is a major challenge for the coming years. This evolution leads to a high increase of energy consumption, but also develop a need to guarantee the quality of services for all users. These problems are becoming large-scale problems with increasing complexity. This is why we need to devise new efficient algorithms based on AI solutions. My name is Tournaire, and I'm interested in solving such problems. This is why I started a PhD at Nokia Bell Labs France in the Human Augmented Connection team in February 2019. I had the chance to work in a CFA program with University Telecom Sud Paris. I am thus benefiting of industrial approach and academic approach, exchanging with several colleagues in Nokia Bell Labs and at university. I'm currently focusing my work on reinforcement learning algorithms, where the goal is to learn a good planning policy by interacting with the environment. The use case I'm investigating is resource allocation in the cloud, where we want to know how much resources we need depending on the demand. The first approach was a model-based approach, where we modeled the system with queuing systems and Markov chains and proposed several heuristics to find optimal threshold policies. For this work, I had several publications in French Congress and international conferences. In parallel, my team at Bell Labs also worked on the same subject, but in a more complex setting. Since the system is more complex, they decided to tackle the problem with a model-free approach with classical Q-learning algorithm in single agent and multi-agent setting. To help the team, I devised the Matlab-Simulink Simulator to simulate the behavior of the environment. The simulator was useful to understand the transient dynamics of the system and also to run reinforcement learning algorithms. However, current solutions still suffer from curse of dimensionality if we want to consider problems in higher dimension, mostly because classical reinforcement learning methods does not take into account the structure of the environment when they learn the policy. This is why the future goal is to integrate such structural properties of the environment into AI algorithms in order to obtain better performance. One way is to model the causal relation between the variables of the environment in order to plan efficiently. My will is then to apply these new techniques to some Nokia's use case. Beside my work, I also had the chance to participate in many conferences and summer schools in which I met other PhD students, and I also had pleasant moments with my colleagues of Bell Labs. To summarize, I'm a passionate PhD student in Bell Labs teams trying to solve concrete telco problems with Markov Decision Processes and reinforcement learning algorithms and new AI solutions, and I hope that Nokia will benefit from these solutions. Thank you.